Oh, yeah, that's it.
Oh, okay.
I just check myself. Now I'm recording. Okay, so the multiples of 9 are 9, what? What are they? 18?
27, 36, 45.
Right? Etc. Multiples of 12 are 12, 24, 36, 48, etc. And we see that we get a match the first time we get a common multiple in those lists is 36, right? So that works fine. Now that's not going to work as well for algebraic expressions though. It's not so easy to think about multiples of algebraic expressions, right? So we got to come up with a different method. Just as reliable, just works just as well. There's another way to go about this. Well, what's another way I could find the least common denominator? Can you think of one? If you, well, you can. If we do 9 times 12, we're going to get 108, which would be way down these lists. But we want to get the least, not just a common denominator, we want the least common denominator. Now, why is it, if I multiply 9 times 12, let's think about that for a second. Why is it that I get a number that's too big, do you think? It's bigger than it needs to be.
Because it's not simplified.
Okay, but simplify, okay, I think you're getting at the right idea.
Could we factor?
Okay, what could I do I could factor the denominators, right? So what if I factor 9? What's 9 work out to be?
3 and 3.
So if I factors of 9, let's just do a little. So 9 breaks up into 3 and 3, right? So if I'm looking at factored form, 9 is equal to 3 squared, which is the same thing if we want to write it as 3 times 3. Okay, what about 12? 12 breaks up into 3 and 4, and 4 breaks up into, if we want to do prime factors, 2 and 2. So 12 is equal to 3 times 2 squared, or if I want to write it this way, it's 3 times 2 times 2. Okay? So if I want to find the smallest number that they both divide into, I don't really have to take the product of all of those factors, only the ones that aren't common, right? They share a factor here. Look, they share the factor, they each have a 3, right? So if I want to get a least common denominator, I just need to come up with, and this is the important point, I just want to come up with the shortest product of factors that's going to include two 3's, right? A 3 squared and a 3 times a 2 times a 2. So it's got to include those 3 and those 2. But how many 3's am I going to need total in my, well, no, how many factors of 3 am I going to need in my least common denominator if this guy right here, this denominator needs 2 of them, this one needs 1 of them?
3.
No, I don't need 3.
1. 2.
I just need 2, right? I mean, you see why? Here, yeah, you're going to get it eventually. That's the shotgun method, I guess. So I only need, in my least common denominator, I only need 2 factors of 3 because that's more than enough for the factor, or for the denominator 12, and it's just enough for 9, right? So what is going to be the shortest list that includes both of these things and all 3 of those things? They share a 3. So that one I only have to, this one only requires 1, this one only needs 1 more than 1, right? So my least common denominator looks like it's going to have a 3 times a 3 times a 2 times a 2, right? How come? Because this guy needed both of those, and this guy needed all of those. Now, one of them overlap, but that's good, right? That makes the total product a little bit smaller, right? The right answer was 36. If I multiply these two together directly, I got 108. How many times bigger is 108 than 36?
3.
What do you know? It's 3, right? Because they shared a factor of 3, okay? Get the idea? Okay? So then if we want to come up with a common denominator, we're starting off with 2 over 3 squared. And over here, we're getting 7 over 3 times 2 squared. I've got to get the smallest list of, I want to get this on the bottom, right? I want to multiply top and bottom by just the smallest amount possible so I can get the same string of factors in both fractions, right? So with this one right here, I'm multiplying by 2 squared, right, to get that list. And, whoops, hang on here. Yeah, by 2 squared. And over here, I'm going to multiply by 3 over 3, right? So now I get a 3 squared times a 2 squared and a 3 squared times a 2 squared. Oh, you're fine. Okay. Make sense? Okay, questions? Let's try another one. Let's try a little harder one. So what about something like this? What if I've got just ridiculous denominators? This would be hard to do with multiples, wouldn't it? Right? I mean, think about, it'd take a while. If I got to make multiples of 168 and multiples of 1260, those aren't very fun multiples to do. And the list might be really long before I actually get a shared, common multiple, right? But if I just use the same method we used a second ago, this isn't that hard. We're just going to, if we factor 168 and we factor 1260, we can easily come up with the shortest product of factors that's going to include all the factors of 168 and at least all the factors of 1260. Now, hopefully, a lot of those are going to be shared, so we can sort of use them in both lists, right? So let's do 168. What are the factors of 168? So we can make it easy. 2 and what? 2 and 84. 84 is what? 4. How about 4 and what?
21.
And then the 4 breaks up into a 2 and a 2, and the 21 breaks up into a 3 and a 7. Okay, so what do we get? 2 times 2 times 2. So I'm going to get a 2 cubed times a 3 times a 7, right? How about the 1260? I could do 12, couldn't I? That would, we kind of make it a little bit, so it's not so long, maybe a little more even. So I get 12 times what?
15.
1,
5. Yes.
good, 105? Okay. Right, because 12 times 100 is 1200, 12 times 5 is 60. 12 breaks up into, we just did that one, what's that? 4 and 3, 4 is 2 times 2 times 3, 105.
5 and 21.
121 is,
7.
okay, so what do we get then? So we get
2 squared.
2 squared
3 squared.
times 3 squared times 5 times 7. Well, there's a lot of overlap in those lists, right? We're getting 2 2s overlap, and 1 3 overlaps, and 1 7 overlaps, right? So if I want to get a least common denominator, let's just take a picture of those. Okay, so what's my least common denominator? 2. So my least common denominator, how many factors of 2 am I going to have? How many do I need total? I mean, this guy only needs 2, but this denominator needs 3. I have to have at least enough to satisfy both denominators, so I need 3. So I'm going to need a 2 cubed, which means if I want to multiply this by something to create a common denominator, I'm going to end up multiplying this whole thing by a 2, right, to get my 2 cubed eventually, right? How many 3s am I gonna need at minimum? 2. This one needs 3 squared, that one only needs a 3, but I need at least enough to satisfy both denominators. So I'm gonna have a 3 squared, so that one we can multiply by a 3. Next factor that shows up is a 5. How many 5s? 1. And this one's gotta get multiplied by 5 because it doesn't have one, right? How many 7s?
1,
How many?
1.
1, right? Because each of them only needs 1. So I have to have at least enough to the minimum number that's gonna include all the factors of 7 in both denominators. So that's my least common denominator. To get it, I only had to multiply 1260 by 2, but I had to multiply 168 by 15, right? Okay, so if we go back to the problem then, what is the problem? We're trying to do this. We're trying to add up, trying to add these fractions up, right? Okay, so I've got to multiply top and bottom of the 11, 168. I got to multiply that by 15 over 15, right? There's my 15. And the 13 over 1260, I only have to multiply by 2 over 2. Okay, but if I do all that stuff, look what happens. My common denominator is what? If I multiply all that out, what's it going to be? Yeah, I can just double that, right? So 2520. And I'm going to get 11 times 15. 165 plus that's supposed to be, you can't see the 1, that's 13, right? Or 26, good. And so we end up with, our answer is 165 plus 26, what is that? 191 over 2520. Okay? That's it. Right? That's our answer. Okay? So now the question is, and you could all do that. I know you could. Right? You've done that stuff before, but I want to just remind you what the process is, right, of adding fractions or subtracting be the same thing. Right? So what do we do with something like this then? If I ultimately want to add those up, the first step is I've got to find the least common denominator, right? So let's look at both denominators. We want to write them in factored form. So this one's already factored, isn't it? Right. So we've got, whoops, how was I going to do that? So we get x in factored form just equals x. How about this one? Four x plus 12 in factored form is what? Four times x plus 3. They don't share any factors in this case, right? If there's no shared factors, then my least common denominator is just going to equal the shortest list that includes all those factors, right? So I need, my constant is going to be a 4. I've got an x, and I've got an x plus 3, right? So that's it. That's my least common denominator, right? No shared factors, so it was just a product of the two. I'd end up having to multiply this one by all that stuff, right? It's going to get this least common denominator, I'm going to have to multiply him by 4 times x plus 3, and I got to multiply this one by x. Okay, top and bottom. What about this one?
Oh my goodness.
You factored both of them out.
Okay, so what can I do with that? What's that going to factor
All
into?
3.
So I'm going to get a 3, and that leaves me with what?
X squared minus 7x.
2, and -5 are the magic numbers. And then how about here?
About 6.
So I'm gonna pull out a 6, leaving me with
Squared.
Minus 1.
minus 25, okay. And then what's that factoring to?
X plus 5, X minus 5.
Okay, so my least common denominator, then I have to build, oh, and what's the 6 break up into?
Oh, nothing breaks into it.
3 and 2, yeah.
Easy.
Okay, so then my least common denominator can be what? So let's do the constants. I only need 1, 2, and 1, 3, right? What other factors do we have? We got an x minus 2, only need one of those. How many x minus 5s do I need? One, right? Each one of them only needs one. They share it, okay? And then I need 1x plus 5. So that's my answer, right? Make sense? Now let's actually add a fraction. Let's add some fractions. So what about here? If I write this in factored form, now let's rewrite the whole sum in factored form. So the first term -5 over x plus 6 over, what's that one factor into? What's this denominator factor into? Okay, so what's my least common denominator gonna be?
Those distributed.
I've only got two different kinds of factors, right? I've got x's and x minus 2's. So that's gonna consist of those factors. How many x's do I need? 1. Each one of them only needs 1, so 1's enough. Times x minus 2. So that is the common denominator, right? I've already got it there. What do I have to do here, top and bottom, to get it?
Multiply by
Multiply.
X minus 2.
Now I got it. There's my common denominator. Right, so this whole thing is equal to x times x minus 2 on the bottom. What do I get on top? So if I expand that out, what do I get? Negative 5x plus 10 plus 6, right? So if I simplify that whole thing, negative 5x plus 10 plus 6 is what?
5x plus 16.
Plus 16 over x squared minus 2x, right? You got it. If we expand out top and bottom, okay, which usually we're going to want to do. Okay, let's do a little harder one.
Fine.
Let's do that one. First fraction, on top I get a 6. What about the bottom? Can't factor out a GCF, but what can I do with that?
Difference squares.
Difference of squares, good. So that looks like
3x plus
a
1.
3x squared minus 2 squared on the bottom, right? So that factors into what?
3x minus 2 plus 3x plus 2.
Okay, 3x minus 2 times 3x plus 2, good. And then how about over here? I've got a 3 on the top. What's it factor into on the bottom? So I can take out an x, it looks like, right? And what am I left with? 3x minus 2. Okay, so I need a common denominator, right? So what am I gonna, to get a common denominator, they share one factor, so we can kind of start to trim this process down a little bit. Look, they share this one, right? So what do I have to, any non-shared factor that shows up in the first denominator has to end up in this one too. So I can multiply top and bottom by 3x plus 2 over 3x plus 2, right? I'm gonna need that one over here, but I'm also gonna need this one over there. Now do I have the same denominators? Yeah, we have common denominators, right? So this simplifies to 6x plus, what's that if I expand it out? Over my common denominator of all that stuff, right? Which is, if I want to expand that out, I just multiplied this one by x, didn't I?
Destroy it.
Yep.
We're subtracting.
Oh, we're subtracting, whoops, you're right. Okay, so if I'm subtracting, all that does, remember, it really doesn't make things too difficult. All it's doing, I'm going to change that to, that's a minus. And those just become minus signs, right? The denominator, the point I want to make here now is the left denominator, I only multiplied an x through, right? So that is the left denominator. So rather than have to go through and reinvent the wheel here and multiply all this stuff out, why don't I just multiply x times, we already know that the product of the two white factors is just that, right? So what's the bottom going to be? 9x cubed minus 4x. Here we go. Okay. You know what might be a good idea though, now that I should mention this. So before we do that, we already know what that's going to be. But I'm just thinking ahead, not even so much to this year, but like to stuff we're doing in calculus right now. And it's not a bad idea to leave the bottom in factored form until we get the top simplified. Okay, here's why. Because when we simplify the top, what do we end up getting in this case? I'm distributing the negative to everything, aren't I? Right? So what's that going to give me?
Negative 9x minus
No.
6. Right.
I mean, okay, you're right, negative 9x minus 6, but let's just combine the whole thing. Sorry. 6x minus 9x is
3x.
negative 3x minus 6, okay? And on the bottom, I've got all this stuff, right? Can I factor the top? What could I factor out on the top? And I'm left with x,
Plus 6.
if I factor out a negative 3, x plus 2, and on the bottom, I've got all this. So it didn't end up being important, but what might have happened when I did that? What if when I factored the top, what if I had gotten, for example, a 3x plus 2 up there? I would cancel it, right? And I can simplify this further, right? So do you see strategically that when you're doing these kinds of problems, you really want to make sure you simplify the top before you write the bottom in expanded form, what's already factored, right? And our goal, the further you get along in math, the more important it is to have things in factored form. Like in calculus, that's all we ever really want. We want to have functions in factored form because we're always looking for zeros of functions and the derivative functions and the second derivative functions. We're always looking for common factors and zeros. So we really always want to, almost always, want to have these things written in factored form when we're analyzing a function, right? So why undo all that important work? We've already got this thing factored. There are no common factors, and so now we could go through and write it in its expanded form. Well, here's my negative 3x minus 6 we had on the top, and you already told me on the bottom if I multiply x through by that, I'm just going to get 9x cubed minus 4x. So that's my answer. Okay? You get the idea? Yeah, I think you just gotta try it. There's an assignment up there, not a long assignment. It's got problems with yours, there's gonna be a section on finding the least common denominator, a section on adding, setting on a section on subtracting, like 2 or 3 problems in each one. Yes, sir.
Sam had this question, does
Yeah.
orange have 1 or 2 syllables?
Does orange have 1 or 2 syllables? That's a good question. Orange. You know, I think the way most people say it.
Somebody asked.
Oh,